in here.
Recording. Okay, welcome everybody. I just turned on the recording, so I think we might as well get started. Good to have all of you here. I'm going to mute you, Snedicor. Sorry about that. So welcome. I was asked to give a quick chat about carabiners. And this is a subject that everyone kind of thinks they know, and they know really, really well because they've been doing it for a long time. And then when I started actually trying to write down everything that I could figure out about carabiners, I realized there were a lot of gaps in my understanding. And so I ended up writing a fairly decently long paper on it so I could learn about carabiners. And so if anyone is interested, let me share my screen really quickly here. This is the paper that I read. It's up on my little nonprofit webpage if anyone wants to go there. It's this thing right here. It ends up being some 20 some odd pages of pictures and details about carabiners. It's free to download. You're welcome to take a look at it. I don't think I'm going to get through everything that I put in here, but I'm going to make a good old college try. So that's where all the information is coming from that I'm going to chat about this evening. So the goal really is to give you guys the background on carabiners that I never got. And I wish someone had taught me. And so we're just going to go through this. Please feel free to stop me, ask questions, put things in the chat, or unmute yourself anytime to ask questions or make comments. This is really more of a discussion than it is me talking at you. Okay. So let's first off start off with some carabiner anatomy, just to get everyone kind of on the same page. Number one, here's a carabiner. I've got a bunch in front of me, but there are a few parts to be aware of. Number one, this is kind of the basket or the top of that carabiner, like the top bar or the basket. And I might use some of these terms through the talk. So there's your basket. The spine is this long end opposite the gate, and the gate is this bad boy that moves. Okay. So that's just the general anatomy. What you find on the vast majority of carabiners is a series of markings. And these are the markings that you find on the spine. Okay. And I hope that was clear. If not, you know. And basically all carabiners that are rated or safe for climbing will have these markings on them. Now, if you've got a carabiner that doesn't have those markings, please don't use it for anything life safety. Right? Because if it's a carabiner that's made by a reputable manufacturer, it should have little markings on them. Now, the markings will usually tell you a few different numbers. One is how strong the carabiner is when you pull it end to end. One will be how strong it is when you pull it from the spine through the gate. Another one will be end to end with the gate open. And usually they're somewhere over 21 kilonewtons to about 31 kilonewtons for a normal average carabiner-ish. Okay. Let's see, last thing I wanted to bring up. Oh, right. The other thing about carabiners is something called the gate opening. So if you take a look at this carabiner, you see that when I open it up, it's got this really big opening right up here. If you take a look at, say, this oval, you see that opening distance is smaller. Okay, so I'm going to briefly chat about that kind of as we move through this. Okay, so that's the gate opening. So far, how are we doing? We going too fast, too slow? Good? Okay. So let's take a look at, let's see here, carabiner shapes. There are basically 4 different carabiner shapes, common carabiner shapes. The original carabiners were like this. They were oval. And oval carabiners have a series of characteristics, which I'll get into. But that's the oval shape. That was the original carabiner shape. The next one that you see pretty commonly are these guys right here. This is a D-shaped carabiner. Got a nice spine, and then 2 asymmetrical portions to the carabiner itself. And you can see, relative to the oval, that there's a distinct spine and a distinct shorter side to that carabiner. The oval will have equal length sides, more or less. It looks like the ovals look like a screw link that doesn't have a locking mechanism, essentially, and is a lot bigger. Okay, so there's your D. We also have kind of offset Ds. This is an offset D. So if you take a look at the Ds, you can see that here's our D-shaped carabiner. This one right here is an offset D. It's got a little bit longer top bar. See the top bar? It's a little bit bigger. And that gives it some properties that are interesting. Okay. And both of these carabiners have different strengths and weaknesses. You can use them for different things. Then the last type is this one. It's the HMS or pear-shaped carabiner. You can see that it is a little bit longer than the offset D. You can see that that top bar is a little bit longer, and it's really designed to have a motor hitch tied on it. Okay, that's really its function. So there are your 4 different types. Let me pull those out really quickly for all y'all. Right, we have the oval, the D, the offset D, and the HMS. Okay. And each one of these carabiners have different strengths and weaknesses. None are really better than the others per se. They're just better for different functions. Okay. Any questions on those general shapes? Or Skippy-tastic? Okay. Briefly here, I want to mention this, and that is that there are carabiners that come in different shapes. There are specialty carabiners that are used for very specific functions. And I mean, I got a bunch here. I can go over all of these at some point in time. The point is you'll see a variety of different types of carabiners on the market. And the thing with these specific shapes is they're made for a specific function. This one right here is designed to be used with a petzl stop or a bobbin. This one's designed to be used with some sort of belay device in a clamming context, right? It looks like John's got some little something. I don't know what that is for. What's it for?
So it's the same as like that rock lock you had right there, where this end goes on the harness, this end goes on the belay device to prevent cross-loading.
Right.
Is it necessary? No, but it's cool.
Cool. That's probably Canyoneer logic. Cool. Point is, is that these different carabiner shapes do exist, but they're designed for very specific functions. So these are carabiners that you buy if you're like, oh, I really would like that particular function, and they're less useful for other types of functions. So less versatile equipment, but is very useful for one very specific function. Okay. So, and I'll get to those in a minute. Now, let's talk about what these things are actually good for. So what are ovals good for? The cool thing about oval-shaped carabiners is these guys are actually the weakest of the carabiners as the general strength of a carabiner goes. They are the weakest. But here's the deal. They always have that same strength, regardless of what you do to them. And I don't mean like open the gate here. What I'm talking about is if you pull like with 3-way loading with a oval-shaped carabiner, they tend to retain their strength. So in tri-loading and in weird shaped loadings, these guys retain their strength. That is not the case for a D-shaped carabiner. If you load the carabiner on one of the noses, like out here on the nose, that tends to reduce the strength by up to 30–40%. That is not the case with an oval. So the oval-shaped carabiner is like it's the weak stepsister or stepbrother of all of these carabiners, but it always has the same strength, more or less. So if you're looking for a carabiner that can handle multiple different configurations, an oval is a really good one. Now, the horrible thing about the oval is that it's got the smallest of the gate openings, right? So if I'm trying to open this thing and put a whole bunch of stuff in there, I can't do that. What I want is I want something that's got a much larger gate opening, which is something like the HMS, the pear-shape, or the offset D. These guys have considerably more gate opening than the oval does. Okay. Let's see here. The other thing is these guys have, they're just harder to clip in general because you notice that see that nose on that carabiner? It's very straight down. And if you try to clip it while you're hanging from something, it has a much harder time to clip. Now, if you're trying to clip something in a rush, Something like an offset D or an HMS is going to be a little bit better. Or if you use something like this, here's a climbing beaner, you see that nose is not quite as sharp. It doesn't go straight down as much. It's easier to clip. So as clipping goes, the ovals don't do quite as good a job. And so I don't like them in applications where I have to clip and unclip quickly. So I don't really like them on my cow's tails personally, just because they're harder to clip. With that said, some people really love them on their cow's tails. To each their own. Okay. Let's see, the Ds, the D-shaped carabiners, their strength is the highest. They have the highest strength of all the carabiner shapes. The only problem is it's only when you use them in the exact manner of function, pulled from end to end, right, from up and down. If you start pulling them in 2 different or 3 different directions, right, these guys lose their strength very rapidly. So if you have an application where you need that carabiner to be in one location and there will be only one direction of loading, a D-shaped carabiner is fantastic for that. It's not as good if you're going to clip it to multiple different things simultaneously. Okay. These guys are a little bit heavier than something like an oval or some of the smaller carabiners, which can be a little bit too bad. Now, D-shaped carabiner, or the offset D-shaped carabiner, is interesting because it's got a lot of strengths and a lot of weaknesses, and all around it's kind of in the middle. So its strength is just slightly less than a D, but it's still pretty high. It's really strong. It's got a very large gate opening compared to the oval or the D-shaped carabiner. So it's bigger than both of those two. This top bar is not quite big enough to run a munter hitch smoothly, but you can still run one if you need. So this carabiner basically does it all, but it doesn't do everything as well as any of the others. So this is a good overall carabiner as far as its shape goes. So it's multifunctional. And the last one, of course, is our wonderful pear-shaped carabiner. This bad boy is really the goal here is to run a munter hitch. That's its job. It also has a really big gate opening, so you can clip a lot of things to it. And even if you have a whole bunch of things clipped into this top bar, it generally speaking doesn't reduce the strength of that HMS carabiner too much, only a few percentage points. Unlike something like a D-shaped carabiner, where if you put a whole bunch of things in here, it actually weakens the carabiner as a whole. So, yeah.
That last one you had, the gate on that was offset, wasn't it?
What the gate? Yeah, that when you open it, it pulls off to the side. Yeah.
That's cool.
Sure, if you say so.
Well, it's open wider it gives you a wider opening with the same frame or whatever carabiner, right?
Yeah. In fact, where's the other one? I grabbed like all of my carabiners and pulled them out so that I could do this. So here are 2 pear-shaped carabiners that are basically the same size, and we can compare their gate openings. So this guy right here, that's its gate opening. If you look at this one in my right or left hand, if you twist it to the side, you can see you can actually fit just a little bit more because the gate opens at an angle. That's what John's talking about. I love HMS carabiners. I'm sold on these bad boys. With that said, they're good at some things, bad at others. Right? They do tend to be very large, and they also tend to be very heavy. So these things, if you compare them to something like a small oval or a small D-shaped carabiner, they're pretty hefty. So like I think about these 2 carabiners when I think of that. This little itty bitty one is really strong and it connects 2 things, but it can't do the things that this HMS can. Now, there are a couple things about the carabiners themselves that you should be aware of. And that is the shape of the bar they're made out of. Now, there are some carabiners that are made out of circular bars. Now, if you take a look at this, if I rotate it, you see that bar that it's made out of is a circle in cross-section. If I cut it with a hacksaw, it would be a circle. Right? Other carabiners, when they're built with something, they're built with a bar stock that's kind of an I shape, almost an I-beam. And you can see that when I kind of rotate it around, it's got a different shape. It's got that little groove down the sides. Now the ones that have the grooves down the side are no weaker. They're lighter in comparison. So these two carabiners actually came from the same manufacturer. They're made from the same basic design idea, which is a small carabiner that's full strength. And what you see with this little itty bitty guy is it's a lot lighter. So if you're looking for carabiners that are considerably lighter, you don't want to have all the mass, these little guys with I-shaped bars are really handy. Now you'll see a bunch of carabiners on the market that started out as a round bar and they flattened it. It's not as in vogue anymore, but that is a flat, round bar, essentially. Right? Now, what are the pros and cons of each one of these? Well, the cylindrical bar tends to be cheaper. It takes less processing in the manufacture of that carabiner, so it tends to be cheaper. It also increases the wear time of that particular carabiner. So something that's I-shaped will wear out quicker if there's a lot of abrasion. So things like pear-shaped carabiners where you want to have a lot of abrasion due to motor hitches, you see most of those are circular bar stock, right? Here are two different carabiners, they're circular bar stock, okay? The I-beam tends to be lighter. It tends to be more expensive because it takes more processing. And it does decrease the wear on the lifetime of that carabiner. This is a bigger deal, I think, for people who are climbers, where you might want to, like if you're doing a big wall climb, you really don't want those extra ounces. Okay. Now, there are a few things that carabiners can be made out of. And there are two general categories. You've got aluminum and you've got steel. And obviously you can't see the difference between the two, but you know, here I've got aluminum in this hand and steel in this one. And there's a bunch of different types of combinations. You have pure aluminum carabiners, you have aluminum that's anodized, so it's got a coating on the outside that's wear resistant. You can have stainless steel, you can have some sort of steel alloy, you can have zinc plated, and then you can have a metal alloy, okay? Oh, and I'm sorry, I'm missing comments in people are making on the chat. I'm sorry, I missed all those. Debbie, the paper is on SAR cubed. Yes. Oh, yes, and thank you, Bonnie, for mentioning this. This would make it into one of the early ACAs. Sorry, I missed all of those. Okay, here's the point. Is that generally speaking, you're going to buy either an aluminum carabiner or you're going to buy a steel carabiner. And there's very little difference in terms of strength. The steel carabiners can get up to, you know, 40 and 50 kilonewtons in strength, but generally speaking, that doesn't matter, particularly for caving use or for sport use, because you die at 12 kilonewtons. So if you've got a carabiner that is stronger than 12 kilonewtons, the rest is pretty much academic. Now, there are configurations that will double the strength or double the impact force, so having a carabiner over 24 kilonewtons is a good idea. And so you see most are over 27 kilonewtons in strength. But the reality is that you don't need a steel carabiner. The aluminum is just fine. So the only real reasons to use steel is for wearing. So if you can get a steel carabiner, these are fantastic for things like munter hitches. And I don't have any steel HMS carabiners because I'm too lazy to try that. But generally speaking, for sport usage, we just don't need this. We just don't need it. Okay, they're more expensive. They're really heavy. We don't need the extra strength or the extra wear capacity. So that's kind of my 2 cents. As far as anodization, I think I've got a couple anodized carabiners here. So here's an anodized carabiner. You can see right here on the gate where the bar was made and it was coated in a coating that's wear resistant. And then once the wear resistance comes off, that little that material comes off, it wears very quickly. So the anodized carabiners, they do improve the lifespan of the carabiner, but for the most part, not a whole lot. I don't really see a lot of benefit to anodization. And actually, I should probably ask Bonnie or Andy, have either of you had good success with anodized carabiners at all? Or not, or no? They may not be there.
Sorry, I wasn't still looking for your paper to put a link on.
Oh, okay. I can actually grab that in a second if you want.
Did you say anodized
Yeah.
carabiner?
Have you had any like good or bad experiences with anodized carabiners?
I don't think any bad.
I just haven't seen much usefulness to anodization. I mean, it improves the wear on it just a little bit, but I haven't seen enough for me to care. But that's just me.
Yeah, I don't think we own any. I've seen some in the NCRC cache.
Yeah, yeah. So basically, you got aluminum and steel. For the most part, for us, we're just going to need aluminum, right? No big deal. Okay, so there are a bunch of different gate shapes. I would like to find a very specific carabiner of mine, which may be missing in action. I think it's missing in action. Okay. It's probably down in Canab where I put everything else. So there are a few things about gates to be aware of. Okay, number one, you can have kind of two different types of gates. You can have a gate that is, grab two of these. We can have a locking gate and a non-locking gate. So this is a carabiner that does not have a locking mechanism. This is a carabiner with a locking mechanism. They're for different functions, number one. Number two, you can also have gates that have wires on them. And my one and only wire gate carabiner is down south, but I can show you this one. This is a wire gate for the Freno. Okay. Now the wire gate carabiners are just as strong. The only difference is the gate itself is much easier to break open. Now that's really not a big deal in things like climbing quick draws. They are simply fantastic in that application. They're easy to clip. With that said, for most of us, our caving applications, having an actual hard, solid locking gate is more useful. Okay. There are also some other gate shapes. And let's pull up these two examples. So both of these are non-locking carabiners, and you see that this gate right here is straight, and this one is bent. This is meant for quick draws. These are for when you are clipping ropes. The idea is that you kind of grab the gate just a smidge, and you can clip that rope in there really easily. There's really no application of this for this in a caving application unless you're doing some lead climbing, in which case it's really, really just a climbing context on the ground. There are a bunch of different types of noses to carabiners, and these I only have a few examples of, so I might have to refer to the paper here. But here's the classic type of nose to a carabiner. So when you look at this nose, you see there's a hook right there. And that hook is a pain in the ass. The problem with the hook is that when you're trying to clip things, what it'll do is it'll snag on stuff. And so, what, 10, 15 years ago, people figured out what you do is you give it one of these things, a key lock nose. And a key lock nose works a lot better for clipping things, ease of clipping. And so what I did is I had a bunch of carabiners that originally I purchased, and they had these guys, these had these hook noses. And what I did is I got rid of them all, and I replaced them with key lock noses. Okay. You can also get key lock noses in wire gates as well, which I may have a picture of. Yes, I do. And give me just a moment here, and I will show that to you. Oh, share screen. Okay. So here's, let's see, let's blow this up just a smidge. So here's your key lock nose right here. Here's a key lock nose as well. Here are two wire gates. Here's a wire gate that kind of clips like normal. Here's a key lock wire gate, right? Those are the two right there. So you notice with the screw, or not the screw, the key lock noses, they're just a lot easier to kind of clip on and off things versus these hook noses that tend to snag on everything in their monkey. So that's kind of what we're talking about. Okay, let's get all that back to where I wanted it to be. Okay, how are we doing? Any questions so far? Were we happy so far? Okay, cool. Okay, so when it comes to kind of the gates, the non-locking carabiners tend to, they unlock a lot easier. They can clip onto things easier and unlock a lot easier. So if you want to have a carabiner that's going to hold for pretty much any context, you want to go with a locking carabiner. For most of our caving applications, locking carabiners are appropriate. There are a few times where you might want a non-locker, but most of the time you want lockers. As far as wire gates go, they tend to be lighter in weight, and so they are fantastic for climbers. They clear snow a lot better, ice and mud a lot better. They have much larger gate openings than something like this does. But the gates are considerably weaker and they open a lot more readily. Okay.
Hey, Tom?
Yeah.
Should we get like the screw-on lock or should we get the automatic lock?
I'm glad you asked this question. Let me go through two other things and then I will answer that question because I have some very strong feelings about this, and I'm sure if I ask everyone else, they'll have strong feelings. And the short answer is it's your personal preference, but I go with screw gates personally, and I'll show you why, or I'll tell you why in a minute. A couple other things with gates. Generally, for caving applications, a straight gate is more appropriate than a bent gate is. These are really for climbing applications. These tend to be a lot cheaper anyway and easier to manufacture. The one thing that I did want to bring up, which is what John mentioned earlier, is hinges on the gates. And I've got two carabiners I showed you before, and you can see that this carabiner here, the hinge on the gate makes the gate move off to the side. Okay, so when I open it up, you can see that it pulls off to the side, unlike this carabiner does. And the only advantage to that style is that it gives you a larger gate opening. The other issue here is some people do find it more ergonomic, and I don't know if John's ever played this with this before, but if you're right-handed, this pulls right into the palm really nicely. Versus when I'm opening this one, it doesn't really end up in my palm. So there are some people who do consider this to be a lot more ergonomic. And I will tell you right now, in my hands, it feels better than this blue one, okay, for what it's worth. Okay, so let's go on to locking mechanisms, which was the next thing anyway. And there are a bajillion different locking mechanisms. The classic locking mechanism is this bad boy right here. It's a screw lock. Okay, and what you do is you simply screw it to lock it down. We're all basically familiar with that. There are also a variety of auto-locking sorts of carabiners. Here's a nice auto-locker where I have to turn it to make it open, right? And it automatically shuts and locks. So as long as I hear that click, it's locked. And for me to open it, it takes two moves, 1, 2, okay? Or really just one, it's a one and a twist. You can also get locks that are set up, there we go. This one's set up so that it can't twist on its own. For me to open it, I have to lift it up and twist it. So there's two motions before me to get it to open. Okay, gotta go up, gotta pull up, then twist it, then open. Okay, so there are two motions there, up and twist. You can also have carabiners that have 3 motions. I hate this carabiner, okay? For this to work, and you can kind of see the mechanism down here, I have to pull down. I've got to pull down, and this is why I hate it. And I got to twist it, and then I got to twist it enough that I can open it. And I can keep it locked so that I can just twist it and open it, or I can get it locked where I just can't undo it at all. Okay. There are also specialty locking mechanisms. This is like a, what is this, the magnetron or whatever they call them? These ones are magnetic. So what you do is you just open these bad boys, it opens up just fine. It's magnetic lock. Now, and I think I've got a few others. Here's another one. This one's also a twist and open. And I think I think that's all the different locking mechanisms I've got. Just check and see. Yeah. Yeah, those are all the locking mechanisms I got. So, as far as which one to get, the thing with a screw gate is that you're going to screw it down and it stays closed. The advantage of having like a second mechanism is that you can, these things can kind of jiggle open if you have them oriented the wrong way. Fine. The problem with these mechanisms that I see, number one, is they can get jammed with sediment and it's hard to open and close them. But number two, they're always locked when you really, 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 really have to open them. And it's a pain in the butt. Okay. There are definitely moments where I'm like, I got to open this carabiner, I got to clip it to something, and I got to do it quick. And I'm, right? So personally, I do not like these guys because they lock for me, and there are times when I do not want my carabiner locked. So that is my personal preference. Okay. If there is a time where I absolutely want my carabiner locked, what I do, and this is what Bonnie mentioned at the beginning, is I use a screw link. Okay. If I want my carabiners to be just shut and locked constantly, I use a screw link because it's not going to come undone. Okay. Now there are a variety of different other locking mechanisms. In fact, I'll share my screen again here and show you just a few. Okay. Share screen. So here's a bunch of different locking mechanisms. I showed you the screw gates, the 1-motion, 2-motion, 3-motion carabiner gates. You also have gates that are ball locks where you have to press a ball and usually twist them to open. Then you have some of these weird shaped carabiner gates where you have to open up 2 different mechanisms simultaneously. Again, a colossal pain. My 2 cents is that I really like the screw gates just because I have to lock them. I also have to unlock them. So it makes sure, I get the carabiner that I want when I want it. Unlike these auto lockers where they are always locked, even when I don't want them to be. So that's my 2 cents. Bonnie, do you have any?
There's only one time that I really like my auto lock, and that's when I'm hanging my kids off of me.
Yeah.
And I don't want them messing with the carabiner. Not that they would anyway. It's just that's the only time I've actually found the auto lock to be useful.
Yeah, I agree. Ammon, did that answer your question at all, or?
Yeah, because I mainly use an auto lock for my main D-ring that I hang my cow's tail and everything on, which I like because it just locks itself. And then for like the end of my cow's tails, I use a screw-on lock, and it seems to work better that way.
Sure. I mean, the end of the cow's tails, it's also perfectly valid to use non-lockers there too, depending on your application. For me, I'm doing a lot of transitional anchors, so I really like having lockers there, but there's a legitimate case to be made for non-lockers there as well. So for what that's worth. Okay. Sorry here. Okay. Let's talk about size for a minute. No, it's not always about size, but right now it is. Okay, here are 2 carabiners. Both of them are D-shaped carabiners. This one's very light. This one is not, okay? This is fantastic for applications where you're just going to connect 2 things and they don't have to be very large. This carabiner will work in that same application, it's just heavier. Sometimes a smaller carabiner can be very useful. With that said, sometimes the size of the character is integral to its function. Okay? I will give you these 2 carabiners as an example. These are both HMS carabiners. This one's a little, what is it, Metolius, I think it is? No, it's a Petzl. Okay. And this little guy, if I try to run a 11mm rope and a munter hitch on it, I can do it, but it's not happy with me. Okay. So the strength of this particular carabiner is that it can run a munter hitch. The problem is it doesn't really work really well on a stiff caving rope. So sometimes you say to yourself, well, I really want to bring that smaller carabiner because it's lighter weight, it doesn't take as much room on my pack, but it also might destroy its function. And that's the same thing, the same problem with these little guys. Okay, if I use this for putting 1-inch webbing in it, that 1-inch webbing is actually wide enough that it's going to start reducing its strength in that D-shaped configuration. Now, if you're using it for, say, connecting your foot loops, you're going to have like a barrel knot down here, and you're going to have a little piece of metal right up here. This is a perfect tool for that job. But if I want to rig with this with webbing, and I want to have something like a basket hitch or wrap 3 pull 2, this will actually weaken this carabiner statistically because it's so small, right? And so I'm not against small carabiners, just be aware that some of the functionality of a carabiner is based on its size. So if you're going to do things like try to use a small oval carabiner, I would recommend instead get a screw link, because this is designed to be the replacement for this when it's small. There are also very large industrial size carabiners, and I don't really have any of those. I think the best I have is this guy. It's a D-shaped carabiner, and it's just a little bit bigger than, where'd it go? Just a little bit bigger than this one. You can get industrial size carabiners. They really are for industrial use. I don't really see much benefit to our own personal caving usage. I think the only time we really use those is when we're rigging for Furno litters. So with that said, a normal size carabiner is probably the best. What I will say is when it comes to HMS carabiners, get a full sized. These little guys, they're a pain in the butt. They really are. And I find them to be useful, but only when I'm using like 9mm rope. So if I'm canyoneering and I want a substandard piece of equipment, this is what I'm going to use. Said that just for you, John. Okay. Now,
I think being nice to you.
I know. I couldn't be nice for too long. I felt dirty. So you can also buy carabiners with a whole bunch of different color patterns. And I find these to be useless for most caving applications, but they are useful if you're going to do things like rack up and you're going to do some big wall climbing. Because different carabiners can correlate to different sizes of equipment. Now, in a caving context, if you need protection, by all means go for it. But for the most part, the color of your carabiners is somewhat irrelevant. I will say that finding this carabiner on a cave floor is a lot harder to do than something like a gold carabiner, right? The gold is easier to find, but other than that, there's really no advantage to having particular colors. Let's see here. Miscellaneous carabiners. Okay, I brought this up before. Let's explicitly talk about these things. Miscellaneous carabiners are really good for one function. And I think that's really important to state explicitly, because if you want me to, say, rig a pitch, and I have used one of these things to connect my rappel device to my harness, I can't pull it out and use it for rigging. It's less versatile. Is that bad? No, it's just a choice. And this particular carabiner would actually be just fine as a rigging carabiner. But this gets to be a bigger deal when you have some of these integrated pulley carabiners. Because as a carabiner, this is actually a little bit weaker. And as a pulley, it sucks. So it's not a very good pulley, and it's not a very good carabiner. And you know what I can't do with this? I can't rig with it. I can't do a motor hitch with it. I can't make a locking hitch with it. So these devices are funky and they're fun to play with, but they're less versatile. And there are a whole bunch of these that are on the market. I think this is the first one that I saw on the market. Again, it's a full strength carabiner, but you really can't use it for rigging. And the pulley is just atrocious. I would not want to have to use this pulley ever. So personally, if I have a choice, what I'm going to do instead of bringing a carabiner pulley combination is I'm going to bring myself a carabiner and a pulley, right? Because this is a little bit heavier, but it works for more stuff. That's my personal 2 cents. Now, I do know a few NCRC instructors who disagree with me on this fairly vehemently. So this is the world according to Tom, not doctrine, okay? I like versatility in my equipment over Like this is very fast. This is more versatile. Okay. Any questions on anything so far? More or less good.
What is your website? I was told it's not the SAR 3 anymore, that you have your own personal website.
Oh no, it's still a SAR cubed.
Can you post a link for that paper?
Yeah.
I cannot find it on there. Thank you.
Yeah, give me a second and I'll get that for you. Okay, so let's talk about what Bonnie was referring to in the very beginning, because it's a really important concept. And it's actually really broad, and I didn't learn anything about this until about, what, 7 or 8 years into my caving, and it blew me away that no one communicated this to me ever. This is a concept of something called compatibility. Not all carabiners are compatible with with everything else. Okay, and I want to give you a really good example of this. Here is a carabiner, and it's a very small carabiner. It is also a D-shaped carabiner, so it's very strong and very tiny, very light. Now, if I choose to bring with me on a trip one of these things, this is a pulley, and I would like to use these two together. If I clip these things together, do you notice that this pulley is actually hanging at an angle? You guys see that? See how it's not actually hanging straight down, it hangs at a weird angle. Now the problem with this is if I've got a rope running through here, what it's going to do is it's going to rub on the edges. So these two devices do not work correctly in their configuration. The same is true if I choose another, say here's another D-shaped carabiner, okay? There are a bunch of carabiners that don't operate correctly with this device. However, this particular device was designed to work with this carabiner. So you see that when I have this carabiner and this pulley used it together, they hang perfectly straight, perfectly in line. So these two devices are compatible with each other. They work perfectly. And what you'll find with Petzl products is Petzl products are designed to be compatible with each other. But we're Americans and we tend to buy products from a variety of different companies. So what we have to do is we have to actually check to see if stuff is compatible. Okay, so this is a Petzl product. Where's this? Okay, this is, I think, another product. Okay, here is an HMS carabiner with that pulley, and it works just fine. Now, this is actually more common than you think it is. Again, we're going to use this little bad boy. This is a micro traction. It's both one of the more fun and one of the more evil toys that is in the arsenal. If I try to clip that with a carabiner that's too small, again, it operates off to the side. In fact, I've seen this in training before where this particular device gets employed on a carabiner that's not quite correct, and it tends to lock really quickly. So it doesn't really work very well as a pulley in this configuration. Okay. This device is meant to be used with a carabiner with a large top bar. So something like an HMS carabiner or something like an oval-shaped carabiner. One of those two. That's the idea of compatibility. Now, why is this a big deal? That's because of something called dynamic rollout. What I've got here is I've got a rack and I've got a carabiner. If I get these twisted at all, what can happen is the rack can move up and over the gate. See that? Now all it's got to do is break the gate and it pops right out. That's dynamic rollout. Now, if I lock the gate, I'm not going to do this to completion here because I don't want to break my gate here. It takes between about 25 and 35 pounds to actually break that gate. Because to break it in dynamic rollout, all I have to do is break this sleeve that's touching that nose. Can you guys see that? It's just a little itty bitty piece of that sleeve. That's the only thing that keeps you alive during one of these events. Okay. So dynamic rollout means that if you are connecting a rappel device with a carabiner, you have to make sure that it is always loaded correctly. Actually, I screwed this up. Make sure that it is loaded correctly every time before you load it. Now, as it turns out, I'm an idiot. Just ask Debbie. She'll tell you that I'm an idiot. Right? And because I'm an idiot, I happen to know that I'm going to forget. It's buried right now. I'm going to forget to check. And so what I do with my rappel device is I use a screw link because it prevents dynamic rollout. Now, is it acceptable to use a locking carabiner to connect your rappel device? Absolutely. Just make sure that you check for dynamic rollout before you load it. I'm a dumbass. I know I'm going to forget it. So I have to use a screw link for my own personal safety. You guys, more or less, oh, sorry. Yep. Any questions on that at all? I think I have some pictures of dynamic rollout that I can show you.
Tom, or Bonnie, I expect both of you would know. If I remember right, you're not supposed to use the screw link on a bobbin device.
Correct.
Do you remind me why that is?
So with the bobbin, in fact, I think I can simulate it right here. Yeah. It's a little bit annoying. So it's really easy to unlock one of the plates when you've got a screw link. That's why. The short answer why. Let me get this locked down here. Okay, so here's a stop with a screw link. And you see that there's this little teeny arc of plastic here, and to open it up, all you gotta do is do that, okay? Now, if I twist this bad boy a little bit, it actually can touch that sleeve just a little bit and pop it. Like I can actually see it as I'm messing with it. It's twisting and actually bending that piece of plastic. Now, if I pull that out and I put in a full-size carabiner, I gotta oil that screw link. Here's a carabiner designed specifically for the stop, okay? What we have is this device, it's a lot bigger and it's harder to kind of roll. Yeah, like if I try to roll this bad boy, I can't get the bar stock on the carabiner to actually hit that little button. Bonnie, do you know if there, I think there was an accident where someone was using a screw link and a bobbin.
Yeah, so most of the reason that when we teach new people vertical to try and get them to use a screw link with the rack and a regular carabiner with their bobbin is because we've seen people die who do the opposite. And it's not just beginners, it's been some really experienced cavers. So most people, when they start a rappel, they know to check their device, make sure that it's not cross-loaded. But where the fatalities happen is somewhere during the middle of the rappel when the device becomes suddenly unweighted. This is usually at a rebelay or once they kind of hit a ledge and put their weight on their feet, kind of unloading the weight off of the rappel device. And then that's when things get twisted and they don't realize it. Recently in 2019, it was somebody crossing a knot on a rope. He passed the knot, locked his rack off, you know, just like he should have. Didn't do a rappel test, didn't check that carabiner. It was cross-loaded, and he fell about 210 feet.
Yeah.
So compatibility. We're not saying you can't use a carabiner with your rack, but if you do, you've got to check it every single time that rack becomes unweighted. And even experienced cavers forget to do that in the moment.
Yeah, thank you, Bonnie. That it's totally true. I mean, that is why I know I'm an idiot, and that is why I use a screw link with my rack. I kid you not. I know I'm that dumb.
Me too.
So yeah, it is. It is what it is. I wanted to show you pictures of that really quickly. So this was the concept of compatibility that I just showed you guys. Here's the pictures of dynamic rollout. You can see that it's so easy to happen. I've never personally experienced it on a weighted rope, but I have experienced problems with compatibility on a weighted rope before, and it is a pain. So if you're really interested in making sure that your carabiners and your hardware are compatible, here's what I would recommend. And this is going to sound really dumb, but there was a guy, I want to say it was 2012, 2013, who did a NIDERS talk specifically on compatibility. And he said this, if you've got a connection between two pieces of hardware, what you do is you basically sit there and jiggle it. See if you can find a way to fail it, right? And I can't really, I can kind of get it to fail like that, right? And that is one of the known failure modes for a stop, right? So if you've got a question, do the jiggle test and spend a minute, 2 minutes actually jiggling it, making sure that you've got the correct geometry that you want. Okay, let's see, what do we need to end on here? Okay, let's talk about what to buy. This is a hot topic, and I don't want to get shot by anybody. Here's my 2 cents. Buy the carabiner that is appropriate for the context that you're using it in. Okay, Snedcore, you're like, I'm just waiting for it. Buy the carabiner that you need for the particular application. So if you are going to use, say, a Petzl product like this one that is specifically designed for an oval-shaped carabiner, get an oval-shaped carabiner to go with it. If you're going to be doing rigging where you're going to be clipping into, say, a multi-point anchor made out of webbing, you're going to need to have a carabiner that has a wider top bar. So something like an offset D or an HMS is a better choice. What I have found with carabiners is as you get older, they multiply. You put them in a bag and they breed. And so what happens is you end up with this nonsense, you know, just carabiners coming up in the end, okay? Don't do that. Buy the stuff that is useful, specifically for the context you're rigging in. So don't do the stupidity that I did. Actually, to be honest, most of these were given to me, so I didn't buy a whole lot. So buy the carabiner that's useful for what you're trying to do. In many cases, your ovals will be a lot more useful than you think they are. The HMS will be a lot more useful than you think they are, and same thing with the offset Ds. Same thing with the composition of your carabiners. Very rarely are you ever going to need a steel shape or steel composition carabiner. It's just not useful. Okay. Let's see here. Other things. Oh yeah, we should probably talk about optimal carabiner usage. Carabiners are designed, here we go. Carabiners are designed to be pulled end to end. When you start loading them in multiple different directions, they start to lose their strength. So generally speaking, you want to pull them end to end and not along the gates or outward from one of the noses. It's called tri-loading. So here is your ideal shape for your loading. Let me zoom this in really quickly here and give you a good image. On share screen. There we go. You want to use a carabiner in this configuration right here. End-to-end loading. Obviously, loading on the gates, bad, dramatically reduces the strength of the carabiner. Same thing here, where you have portions of the carabiner that are being pulled opposite directions. If you have to tri-load a carabiner and you've got no choice, I'm not sure when that's necessary, but if you're in a situation where you have to tri-load a carabiner, it's better to tri-load the small end than the wide end of a D. And if anyone wants to see the testing data, I can show that to you sometime. Okay. So there's your ideal carabiner usage, end to end. Anything else, it's suboptimal. Let's talk care and feeding of carabiners. In a caving context, the biggest problem with our carabiners is they get jammed with mud and grit. My recommendation for every time you go underground is when you get your carabiners back, or you get back from your caving trip, what you do is you wash them underwater, and then work the gates, make sure that everything gets out of the mechanisms. And that's a big deal when you're in like wet, muddy caves. And when you're done with that, go ahead and dry them out. And if you need to, you can lubricate them. I haven't needed to lubricate carabiners in quite a long time. So it takes quite a bit of abuse to make it so you have to lubricate them. But definitely keep them dry and keep them clean. Even the ones that I've got like on my cow's tails and whatnot, they've all been cleaned. Every time I go caving, I clean them. Last thing is you want to store them in a dry location. Doesn't matter if they're stored in out of light or anything, but I would keep them in a dry location so there isn't any sort of corrosion issues. Also keep them away from chemicals. And this sounds dumb, but the carabiners that are left on cliffside, like seaside climbs, will actually get weathered away. They will chemically weather away from the salt. So wash, dry, and keep your carabiners dry. Now, one last thing about this is that you should be inspecting all your gear every time you use it in the first place. Sometimes we get lazy. Please don't. If you ever look at a carabiner and you think to yourself, you know what? I just don't feel confident about it. Pull it out of rotation. Stop using it. This only happened for me, I think, twice, because I keep getting new carabiners and I have a huge stash of them. If you wear a carabiner down, like for motor hitches, for example, these guys are starting to get used a lot because I've been canyoneering a bunch and keep using them for rappels. If you start seeing that there's a divot in there, right, and you just look at it and you're like, I just don't feel secure, retire it. Officially, you can cut through almost half a carabiner before it actually alters its strength. I don't feel comfortable with the carabiner cut halfway through. Honestly, I just don't. So a rule of thumb is if it's cut anywhere between a quarter and a third of the way through, pull it. Just pull it and it's good. Okay. Let's see here. I think that is pretty much it that I wanted to talk about. Yeah, that's pretty much it. Does anyone have any questions on anything before I show you one trick related to carabiners?
Yeah.
Yeah, what do you got?
Is it safer to use an automatic lock rather than the screw lock to prevent rollout?
No, because the auto lockers, their gates are only marginally stronger. So, in fact, there's a really disturbing video online. It's an auto locking three phase, like 3 rotation auto locking carabiner that people were using for fall protection on a roof. And a guy clips in and he weights it. He's fully weighted on it, and they were trying to reconstruct an accident that occurred. And what happened is this guy took a fall, and he swung down, and because of incompatibility issues with his anchor, the carabiner basically hit the anchor, and the gate ended up touching the opposite side of the anchor. And I mean, it took a fraction of a second for the thing to just, it broke like it was just a brittle piece of candy, you know? So yeah, the auto locker doesn't help when it comes to dynamic rollout. Not enough to care.
Okay.
Yeah. Any other questions?
You were going to post your link for the whole entire
yes.
research?
And I had most of it. Where is it? It's right. Okay, it's not on that page. I'm sorry. Went to the wrong one. Where did I put it? Well, give me a second. I want to show you one thing really quickly before we get out of here. So if you have a stuck gate, and I know a bunch of us have had this happen before, where you've locked a carabiner and you can't quite seem to unlock it in the future, there are a couple things, okay? One is, if you've got a gate and you locked it while you were loading it, you actually are stretching the carabiner as you've got it when you lock it. Or sorry, not when you lock it, when you load it. So if you lock it while it's loaded and you unload it and you try to unlock it, it might be really stiff and hard to unlock. So one solution to that is just load it again. Lean back on it, whatnot, and usually that just pops it undone. Okay, that will usually work. If it doesn't, and I don't know, maybe your carabiner is jammed because you got mud or silt or whatever in it, you can do this. What you can do is take a piece of cordage, like a piece of cordage or webbing, and I'm just going to lock this really quick, and wrap a piece of software around it. What you're doing is you're making a strap wrench. And this works really well with a piece of webbing. I just didn't have one handy, but you can do this with a piece of cord. And essentially what you do is you created a handle and literally a strap wrench to pop that thing open. And this has bailed me out a couple of times. I did a couple Missouri caves where this really came in handy back before I understood how to use a carabiner well. But yeah, making a strap wrench out of things like foot loops or a piece of webbing is quite useful. Okay, any other questions as I try to find this link to this paper?
Was that a clove hitch, or did you just wrap a loop?
Just wrapped it around a few times. Yeah, nothing fancy at all. Here it is. Okay. And here is the link to the paper. Sorry, I just had it on the wrong page. Okay. Awesome. That's actually all I had for you guys today. Did you guys find this to be useful? Did you find things that you learned that you didn't know before?
I'm unmuted now. Yes, Tom, thank you.
Okay, good. It was. I know it's a little rudimentary, and I'm glad people got something out of it. Bonnie, do you have anything you want us to? Sorry, what was that?
Sorry, roommates being
there we go.
professional.
Okay. Bonnie, do you want to add anything that I missed?
Nope, I think you did a great job, Tom. Do you want to maybe talk about, as people go out and start buying carabiners, of course, we're always tempted to buy the least expensive. Do you want to say anything about different brands?
I mean, yeah, that's a good comment. Why don't I show you one of my big mistakes? Why don't I do that? Why don't I teach by experience? So when I first bought carabiners, I was young and dumb, and now I'm old and dumb, so I know a little bit more. What I did is I bought a whole ton of these guys. Okay, these are, I think they're Omegas. Yeah, these are Omegas. Okay, and I bought, what, 8 of them, I think. No, I bought 10 of them because 2 of them broke. They were the most inexpensive carabiner I could find. And they were rated to 31 kilonewtons. And so I was like, oh my gosh, they're rated stronger and they're cheaper. They're clearly better. The problem is that their gates suck. These great gates get gritty and they end up failing. In fact, it got to the point where a couple of these, I could just move back and forth without having to screw them down. And so obviously I had to pull those out of service. Any reputable manufacturer, things like Petzl or Black Diamond or Rock Exotica, any of these will have a good quality product. But please buy from a reputable manufacturer as opposed to buy something, that's a knockoff from China. Some of those carabiners have killed people because they're not rated They might even have markings on them, but they are not actually rated. So whatever you buy it from a reputable manufacturer, and also spend the extra money. A carabiner, a good carabiner will cost you $7 or $8 for a real simple cheap model. A more expensive one might be $15. You know what? That $7 is worth your life. I've been in the situation where I've been hanging 150 feet off the deck and not been confident in my equipment. And the first thing I did is I went home and I said, okay, I'm throwing this out and I'm getting something new. So it's worth the money to buy better. And if you find that you don't have the money, come and talk to me. I have a bunch of carabiners here, and a lot of them are fully functional. Right? I can loan you things if need be. Right? I'd rather have you be safe than using something that's cheap.
I have a comment.
Yeah, what do you got?
A great webinar. Great presentation. You've done a really good job. This would equate really well to a great NSS webinar to store on our archives.
So as it turns out, Debbie, I had a request from a gentleman from China who just asked me to do a couple talks for the NSS so they can be archived. So I've been meaning to email you, and we just had midterms.
Saying that for what, a year now?
I know, but like he's saying he's going to translate it specifically for a Mandarin speaking population. So I need to just suck it up and do it. I've got a bunch of talks I'm doing this month for school, as well as I've got a couple contract jobs I'm doing for some sheriff's departments related to bodies and rivers. And after that, I can do it, but I've got basically 2 weeks where I'm going to be barely sleeping.
Well, this would be April or May.
But yeah, I'm happy to do this one for the NSS. But the one he really wants is my discussion of two tension systems versus main and belay systems. So we should just.
Now, is that the same thing? That's the same thing we did the research down at Tenab, right?
Well, some of that went into that talk.
Okay.
Yeah. So yeah, we should get together and plan when those are going to be. But this month is out. I'm too slammed. Cool. Well, thank you guys all for coming. I want to emphasize this, and I try to say this at every training, but caving really is a family. And thank you for coming to get some more training, even though it's a bunch of people who already know a lot. I appreciate that because we can all learn just a little bit more. And if you guys want to follow up with the paper, you're welcome to do so. There are a lot of details in there that I just didn't include here. What was that, John?
Yeah, if you have a minute afterwards, I have some stuff I'd like to work over with Hall systems.
Okay, we can do that.
Cool.
Cool. Okay, well, thank you all for attending. And yeah, I'll end the recording here.